Alright, you guys, what's good? Here we're going to talk about a dynamically allocated example. So the previous class that we saw, point 3D, was pretty nice. It's a little bit involved because we have, three different types of constructors. We have a destructor, we have a print method, and we have three setters, actually four setters, and three getters. Right, so that's a total of like 11 functions about. And it's kind of pretty involved. Although a lot of them are considered relatively simple, and most of them are one-liners. They shouldn't be discounted, however, but it starts to show what you can kind of do with classes to make them easy to use and makes user usability a little bit better. You can kind of the goal with these classes is to kind of make them as smooth to use as possible. But anyways, here in this video, we're going to talk about a dynamically allocated variable. It's going to be called vector. So I'm going to have some private data, and I'm going to have double, and I'm going to say elem for element, and I'm going to have an int size. Right, so what's going to go on here is that this size is going to be the size of, well, my user-defined vector, and then here I'm going to dynamically allocate data for lm, and lm is going to serve as, well, the element of my vector. It's going to contain the data inside my vector. This is a specific implementation of vector. The vector that you have been introduced to, or that you may have seen in previous videos, is part of something called the standard template library. And std vector is a generic vector, and that is infinitely times better than what I'm about to produce here. And speaking of, what I'm about to produce here is a small, puny example, a very limited example of what's already out there. Don't go around using this as your own data type. This is just for showing what to do with dynamically allocated data and how to create it, clean it up, and all that stuff. You should not be using this for your programs. Use std vector. But anyways, here I have the private data, and I'm going to say public now. All my public stuff, and let's go about the constructor. Well, and let's think about this a little bit. The constructor for a vector is a little bit different than from like a three-dimensional point. Here my vector, it can be another vector, first of all, so we'll probably need a copy constructor. But what am I going to do for my default constructor? Well, vectors, like I've done before, they can look, I've done stuff like this where I have, if I have a vector of integers, then I can do something like that and kind of declare it as a C style array. Right? Here's one way that I usually think about creating vectors, and one way that I go about initializing these vectors. And I think this is a good way to show a specific and new kind of constructor. And this is a constructor with a parameterized list. What is an initializer list? This is an initializer list. So how about we go and create this constructor? Here we have it. It looks a little bit troublesome just because here I have std an initializer list, and then I need to specify what my initializer list is going to contain, what data type it's going to contain. And because I have elements that are going to be of the double data type, I'm going to say double. And this initializer list is going to have a name of LST. So because I'm trying to exercise some habits in modern C++ programming, I'm going to have colon. And because I can declare and allocate data for this LM, here's how I'm going to do it. So LM is a pointer to a double. So I'm going to say LM is going to be initialized with dynamically allocating the size of the list. Right, so here in this example, I have 4. So here I'm going to dynamically allocate 4 doubles. Then because I did that, well, now I need to initialize my size. So I have a comma, I have size, and here I initialize size by casting my input LST. I get the same input as here, right? But instead of dynamically allocating data for this variable, I'm just taking its value and I'm going to cast it as an int. I think This, if I remember correctly, could be like an unsigned integer. I forget. But anyways, this lets us pretty much declare our values for our attributes. Well, this one gets a value, but here we just declare a size, right? So we allocate some empty space for it. And you know, using this as the example, so I've allocated 4 doubles here, but I don't know what the values inside of them are, so I'll need to fill them out. But here, this is initialized with everything. It has its size, which is just going to be 1 because it's just a variable holding 1 value, and that size and that value is going to be list size. So where does that leave us? Well, size is taken care of because it has its value, but LM is a little bit weird because we've allocated the space that we need for it, but those spaces don't have any values. So here we use std copy, and std copy has us give the beginning and the end of an iterable, like an initializer list, and then the destination that we want to copy this data to, which is lm. So here we allocate the space for lm, and here we provided values. And this lets us initialize our dynamically allocated attribute lm. So this is going to serve as our default constructor. It doesn't take a singular value because this class doesn't really take exactly a singular value. As I say, it's attribute of importance. Here, the most important attribute is definitely the lm, the elements, because this is going to be like, you know, an array class, an array-like class. So because of that, I can't just have a traditional constructor like I did in the previous example. I need something more complex, something more involved, and here's how I go about it. But this is just for one type of input. This is for this kind of declaration. I also see myself creating a, my own vector from another vector. So why don't I go about creating my copy constructor? And here we have it. So I have my vector, my const vector v, not to be confused with std vector. This is capital V vector, my class. So I have this constructor, which is a default constructor with an initializer list. And here I have my copy constructor because we have vector, and we have vector here. So how we go about initializing this? Well, we have the colon. I have my lm. Here I'm going to dynamically allocate however many values are in v. I'm going to get that many doubles. It's going to be dynamically reserved into lm. I get that same v size, and that's going to become the size of this vector. And here now what I'm going to do is that I'm going to have a for loop. Well, I could try to put the begin and the end. I actually don't have any methods created for that. So I'll have to go the old school style where I have to say that while I is equal to 0, while I is not equal to the size, we're going to keep copying the elements of v into our own class's elements, and that'll be the end of it, which is relatively simple. And again, I can't use std copy because I haven't defined a begin and an end to my vector class, so sadly I can't use it, unlike this std initializer list where it already comes with, a begin and end for that. But anyways, let's move on. And I actually would like to talk about the destructor. And again, to kind of review, the destructor will have the tilde in front of it and the name of the class. So I have vector here, and simply what I'm going to do is that I'm just going to delete lm, and that's it. And this seems simple and kind of underwhelming, to be honest, but this is very important because in both of my constructors here I dynamically allocate data. It's allocated here, so if it's been allocated in the constructor, well, I need to deallocate it somewhere. My other justification is that these two functions are, either one of these two are going to be called. Whether I give my vector in an initializer list or I give it another vector, either one of these two are going to be called. However, all variables are going to call this destructor. So I need to make sure that when either one of these two are called and they allocate data, that my destructor destroys that data. And lastly, I should work on the getters. So I don't really want to work on some setters for this just because it's a container. And well, actually, not the next method, but the method after is going to be kind of a setter and a getter, but we'll get to that in a little bit. I'm going to have a getter just for the size of my vector, because I think that's something that's important. I always want to see the size of my vector, but I don't want to have anyone edit that, because it's very particular what value that should be, and it should correctly represent the elements in my vector without it being changed. So I'm actually not going to create a setter for the size, just because size depends on LM, and I don't want someone, I don't want to have data that's like 3 elements in a vector, in my vector, and say its size is like 20. I don't want something like that. It needs to say 3. Anyways, let's get to the getter. Here I have it. It's pretty simple. All I have is size. I make the body const, and I just return the private attribute. So that takes care of size, right? So because size depends on the lem, I don't want a setter for it, but I do want a getter because I always want to see what value that is. However, for a lem, it's a little bit tricky, because while I do want to see the contents of it all the time, there are some times where I want to edit it, and it would be a little bit weird. How would I go about creating a setter for that? That's kind of a complex problem. If I want to use a traditional function, it's going to be really weird. Would I have something called like set lm, where I have, an index and a value that I want to set it? Would I want to have something like this? I could do something like that. I could have set lm, and then I can, I have the index, and then, the value that I want to set it to. And, if index is greater than size, I don't know, I could raise an error or something, but there is a better way, and here it is. And now things just got a little bit complicated. So what I'm actually doing here, and we'll cover more in detail, is that I'm overloading an operator. And what this means, I'm just adding additional functionality to an operator that already exists, right? So I'm not changing the behavior, but I'm adding more things that it can do to the operator than what it already has. So the square bracket operators will work fine as I have been using them and how you've been using them in a traditional sense. Just here I'm adding, okay, how can square brackets interact with my vector class now? And here is how I define it. So I actually return a reference to a double, right? So because of this, there's implications. I'm not just returning a double, I'm returning a reference to a double. So not only can I use the square brackets operator to get, an element at position I can actually set one of the elements at position I to something else. Right, so this kind of acts both as a setter and getter. And I mean, this is a little special just because we're doing operator overloading and things get a little bit complex, but this is pretty neat. And with that, why don't I finish up my class, and I'm going to write a main that will test out the functionality of my vector. And here I have my main to test, everything. So here I call my first constructor my first constructor. Here I have my first constructor that's going to be called. It gets called with the std initializer list. Then here I want to print the size, and I need to put my double parentheses because this is a method call. And then here I call my copy constructor, and I copy the contents of f into s. And then here I use my operator here as a setter. And I set, s of 1 to 8. So I change this from 2 to 8. And then here I have s of 0, which will change 1 to 19. Then I have a for loop that's going to print the contents of s. And here I use the operator as a getter instead to see the data that's inside, right? Compared to here where I use it as a setter, where I set the values at that particular index to a value. Here I'm just reading those values. And that's about it. After that, I print a new line. And we're done. So let's see the results of this program. Not too bad. Notice here that I had to do my standard as C++17 just because I'm messing with initializer lists. So at a minimum, I'll need C++11, but I like to use C++17 as a force of habit. But anyways, here I get the size of f, which is 3. It makes sense because I have 1, 2, 3. And then I copy F to S, and I change S of 1 to 8 and S of 0 to 19, and I print those values here, and that's reflected here. We've introduced some concepts. I mean, here we have a dynamically allocated variable, where in the constructor, we dynamically allocate some data, and the destructor, we get rid of it. You know, we free up that data, so we're doing good practices, best practices. So we're not doing some bad habits in our programming. And one last check is I'll check with Valgrind. So here we run it. I had some problems with this option, but here we have Valgrind leak check yes, and with our executable. So we have our heap summary. So we did not definitely lose any data, right? So our data was properly freed, right? It was properly deleted. It was properly allocated, and it was properly freed. And with that, guys, I'll see you in the next video.